Okay, so the first ones you guys are going to look at is right here.
Never mind.
Oh, I hate work problems.
It's boxes. You got this.
It's not just boxes.
Let's start on one box. Let's start with the purple box. We have a purple square here, right?
Yes.
And what information was given?
That's 9
The area.
It's 9.
The area is 9. So, what number times itself is 9?
3.
So this is 3. Is it not?
Yeah, it is.
No, because there's 4 different sides.
It is.
But it's just length times width, or the side times the side. So what's this one?
3.
3.
And 3 times 3 is?
9.
We're good, right?
Yep.
Okay, so next question though. Is there a different way you could have got 3 using something that we've studied recently? What?
Square root.
The square root of 9. If the area is 9, I could say the side times the side is equal to 9, and I could square root both sides, and then one of the sides would have to be 3. Do you know how to use the square root button in your calculator? Jackson, this is it. Stay alive. Let's go to the green one.
4.
Because the square root of 16 is 4. And 4 times 4 is 16.
That one's one.
Let's do the blue one.
2.
Because the square root of 4 is,
2.
and 2 times 2 is.
4.
Okay, so now read the question.
Do you add it?
Determine the lengths of the line segment AB. 2 plus 4 plus 3, AB is 9.
That made me feel so good.
You guys were trying to give up too quickly.
That's too easy.
You guys were like, seriously, I told you it was kind of easy,
I thought I had it.
but you had to really try. You had to really try.
That is so easy.
That's too easy. It's a little too easy there.
I can't just throw. I can't just give answers. You've got to try to figure it out. Okay, these are puzzle problems. But did I lie to you? Did I say that we already had the math skills to figure everything out? We did, right? We had square roots. We talked a little bit about area, and then we had to go, and you guys can all add. So that's not a problem. And if we start with that, we got a calculator. So, okay. The next question is similar. I would be writing some of these pictures down. If your paper is blank, this is not good. I'm a firm believer that what we do in the classroom, something should show up like it on your test. I'm going to put some things down like this on your test. You'll see it again after today, so it's not going to be like shocker, but real similar with a slight twist. Good luck. The quick hint reminders. How did I find the side length for 9?
You put it in the
Put square root.
Or you had to think about this times this equals that. Both have to be true. That's your hint.
I got it.
Keep thinking. You can always verify the thing times the thing has to be equal 10 on your calculator. Okay, so I'm going to need a little assistance. I think we should be able to figure things out. It says we're finding the length from A to B again. So we don't have much clue about that, but we know maybe from here to here, because of this 4, how do we find that length?
Square root of 2 by 4.
You can square root the 4, and 2 times 2 gives you 4. So are you guys cool with calling that 2?
Yep.
Everybody's good with that? Okay.
You can't square root that because it just means square root.
Well, but you did.
Yeah. And then you got it'll be decimal.
So you're saying this is the square root of 10, and that's the square root of 10.
Yep.
And if you multiply them, do you get 10?
2 square root 10.
Wait.
Well, if I multiply the root 10 times the root 10, you get the square root of 100, which we already know that's just a
Now you
normal
get square root
10.
of 10.
So what's wrong with this?
You get square root of 10. You get 10.
Guys, 10 square feet, 10 square feet, you could literally count it out right on the floor beneath your feet. Each of these tiles is a 1 by 1 or 1 square foot. 10 square feet are 10 tiles. 10 is a nice number. But the side length of a square that has an area of 10 is an irrational number. The distance from A to B is how much?
5.16.
Or you just say 2 plus the square root of 10. Okay, but I like that answer you had. The square root of 10 is what?
5.16.
Okay,
Oh,
look.
square root of 10.
Hold on. What's the square root of 9?
3.
3. So the square root of 10 is going to be a little more than 3. So it makes sense that we get 5.16 and a bunch of other nonsense. It goes on forever. It's irrational. It doesn't form a pattern. But this is a little more than 3, and that's 2. So we should have an answer a little more than 5. What do you think now? Our answer is an irrational number. Huh? Any questions about this? Go ahead.
So if it's square root, it stays square root. You don't change.
You can. You can leave it like this. We've left it in simplified irrational form most of the unit. All right. Is there anything here that we haven't covered already in class, just generally speaking, with the numbers and stuff? Okay. Next puzzle. Next puzzle. Good luck. So if you square root the green one, the square root of 27, you should have got, I think, 3 root 3.
Yeah.
And if you square root the orange one, I think we got 2 root 3.
Yeah.
So if we add up these distances, you should have gotten 5 square root 3 as the distance
Told you.
A to B.
I got it.
Let's go.
These distances together give you the whole segment.
Exactly.
Let's go.
What do you mean, let's go? He got it wrong. So let's go.
I thought he had it right, didn't he?
No, he didn't add them together. When I was to add them together, he's like, no, Blair, you're wrong. Oh, you so goofy.
Okay. That's a good point. Let's look at this though. If
There were a couple of people that, when they added the radical, what was inside the radical? Yeah.
so
So you add that.
so you can do this similar to the idea of if I've got 3 eggs and then someone brings me 2 more eggs, how many eggs do you get? 5 eggs. Now you do the same thing with letters as you do with types of radicals. You have 3 of this weird kind of number, and you've got 2 of these weird kind of numbers, but it's the same weird number, so you have 5 weird numbers. Irrational square root 3s, to be specific.
So the numbers in the square root don't change.
No.
It makes sense.
It's just like saying if I had 3x plus 2x, we have 5x's total. It's that same idea of like terms, except you have like radicals. But listen, that's why I've been suggesting to you all along is we've actually done stuff like this before, and it solves it for you. You can, on numbers, square root things are numbers, and you can put it in your calculator, and it will do the math for you. Okay? So we don't have to be fantastic at knowing this is going to be the same. But yes, this type of thing and this type of thing, they are the same, and when put together, you do get 5. That's why your calculator does that. Are we kind of good? Okay, again, we just added 2 irrational numbers together, and we got an irrational result. Ooh, good luck. Now it's super large. Similar kind of question. We're trying to determine the line segment from each diagram. So here's this whole diagram. Here that line segment. And what do we get for the first one?
2 square root 6.
Okay. And how about right here?
4 square root 6.
And over here?
3 square root 3.
My name ain't Elizabeth.
Okay. Now, so our final answer is
6 square root 6 plus 3 square root 3.
okay. And now it is true that if you told somebody that, they'd say, well, what is that? And that would be, you know, I don't know what number that is. I'd have to convert it to decimal. And we'd say, okay, it's around 19.9-ish, whatever, units, feet, miles, yards, whatever it could be, right? Centimeters. This is unconventional, but this is unrounded. This is the exact answer. This is a very rounded answer to just try and make it make sense to us.
Why'd you actually write ish?
Because I rounded, it's an irrational number. It goes on forever. It forms no pattern.
Let that man do
Ish. Yeah, let that man do what he want to do. If I want to wear short shorts all the way up to here,
No.
Don't.
and never legs that never seen the day, a little bit of sunlight.
You wanna match no?
That's the way.
Yeah.
Different questions. There's some twists here. Different questions. Oh, I forgot to go over the answers to the previous slide. We went through these and we learned that each side length in red was the side length. Some tried to divide by 4, but you can't do that. You square root it, and then you multiply by 4 to get the answers, or add them all up to get those answers. And we jumped ahead, and now we're on this scenario. There's a couple parts of this question I don't like so good, so let me help you a little. I'm going to go ahead. This in gray, one of those like that. This is actually going to end up being a rectangle. Okay? And I'll do a quick example. In blue, I'm going to say, what is a square? So one of these is supposed to be a square. This is a square. And you can also know that these little boxes here are squares. They don't do a good job of providing that information well. They said assume each of the sections are squares. That's not true. It's just not. And the large shape itself is clearly, it is a rectangle. It looks like a rectangle. The whole big thing, it is a rectangle. The only things that are actually squares are going to be the green boxes and like the pastel pinkish kind of box. Those are actual squares. So you can do the math with the square roots on them. All right, good luck. We decided, I asked the student if they had a fact that they figured out 1 cent the square root of 24 is 2 root 6. He said, so what does that tell us? We figured out that this length is 2 root 6. And I said, well, what else is true? Well, since that's the square, this is 2 root 6. So we established that. Then we looked at number 1 and said, what are we trying to figure out? The length of side A. And so we just established that this one here is 2 root 6. And then right here, this will also be, Jackson, you alive? And here to here is 2 root 6. Can we find the length of side A?
Yes.
We can add all those up.
8 square root 6.
So the length of side A is 8 square root 6. Fantastic. But what about side B? We know this part. But what about this?
Height of side B would be 3 square
That's true. How'd you get that?
By adding square root of 24 and square root of 6.
Okay, right. You found that this was the square root of 6 right there. And then we already know square root of 24 is that side. So these together make side B. So side B is 2 root 6 plus 1 root 6, or 3 square root 6. So the last question gets easy. We know one of the sides is 3 square root 6. We know the other side is 8 square root 6. And we know how to calculate the area of a rectangle by multiplying the two sides. So we would take 8 root 6, multiply that by 3 root 6, and get something a little less than 150. 144? 144 feet squared. How we doing? This one was a little more intense, yeah. Here's what we're gonna have. Some people are still writing. At this point, we're gonna work on a worksheet. I'm asking the students to, on the front side, do number 1 and number 2. And we'll try number 3. On the back side, they can do the whole thing. The back side is kind of, I'm not going to say easier, but it is a little bit. Maybe the first two are easy. Real quick, the area of the caret section. If I multiply that one times that one, you get 27. Each of these little boxes is 27. So the total area of the carrots is 81. The area of the radish section, each one of these is 12. There are 6 of them. 6 times 12 is, I'm not sure, 72. The area of the lettuce section is also 12. 2 root 3 times 2 root 3 gives you 12. They give you a clue at the beginning to answer number 4. You need the area of the whole space. Well, it says this is a square garden. So this one and this one are the same length. And this one is 3 root 3, 3 root 3, and 3 root 3. So it's 9 root 3 is one side. Noah, Alicia, I've asked you 100 times to turn around today. Noah, focus here as well.
I'm locked in.
No, you're not. If that's 9 root 3, the area of the whole thing is 9 root 3 times 9 root 3. This will give you 243. So you take the 243, which is the area of this whole garden space, subtract the pieces that you have, and it gives you essentially the things not covered or the unshaded region. I think it's 78.
Yes.
It's 78 square feet.
And on the other side, it also tells you what the whole area of the thing is.
243.
Yeah. Some of them found that.
They told you that there as well. Did anyone find the front gate answer?
You know what? There was a bunch of answers, but I didn't even look at that one because I was looking at the other one and I didn't do it.
Okay. We know this is 9 root 3. So you would take the 9 root 3 and you would subtract this part, which is 4 root 3. If you square root that, that'll give you the 4 root 3 for this length here. And if you square root this, it's 3 root 3. So you subtract another 3 root 3, and then the only amount remaining is the front gate, which is 2 square root 3. I didn't know the answer until just now either. So that's the front gate space. And we got that by square rooting the 243 to get the whole side. And then you deduct that one, you deduct that one, and then you'll get 2 square root 3. And that's the whole lesson, that's the whole thing. Good job today, guys.